Hi, everyone. I'm going to be talking about a paper that I was supposed to present at EC, but unfortunately I was sick. It's a paper called The Economics of Recommender Systems, Evidence from a Field Experiment on MovieLens. I'm Guy, and this is joint work with Duarte Goncalves, Daniel Kluver, Ruoyan, and Joseph Konstan. The broad motivation for this project is that digitization has vastly increased the product volume and variety of choices that consumers have available to them. And online platforms have kind of tried to make consumers' lives easier by deploying recommendation systems, which are pretty ubiquitous in the modern digital economy, on e-commerce platforms, streaming platforms, news, social media. Most modern websites that you spend time on most likely employ some form of these. This is the one on Netflix. So you go on Netflix and they kind of combine your previous experience on the platform with other users' behavior and use it to try to predict which movies you might like to watch next. And so these systems have been around for quite a while now. Commercially, they seem to be very successful. And so in this paper, we wanted to ask a really simple question, which is, can we kind of unpack the economic mechanisms for kind of why these systems impact choice? And this question of why we think is important because kind of a lot of the literature has looked at sort of broader societal implications of these systems, looking at how they affect kind of the aggregate sets of goods that people consume. There's relevant antitrust issues, and there's increasing regulation targeting these systems. And so in our view, kind of without understanding the kind of core mechanisms for why are these systems changing user choices, it's kind of harder to reason about these higher level questions. And so the core mechanisms that we focus on here are effectively that recommendation does two things. It can either kind of expose consumers to goods that they're not aware of, right? So I get recommended the good, I've never heard of it before, that makes me go consume it. Or the second is that, we're usually in markets with experienced goods, and so these recommendations may provide information on how much a consumer might like the good. Okay. Now, empirically measuring the sort of causal effect of recommendation, decomposing these mechanisms is a bit tricky, right? So the sort of first challenge is that recommendations aren't randomly assigned, right? By definition, a recommendation for a user on this platform is kind of personalized to them, right? And so to measure the causal effect of this, what we do is our study is going to be within subject, right? So across users, we're effectively going to have an experiment where we're going to have a set of goods that are recommended, which are of high quality. And then we're going to construct, using the estimates from the recommendation system, a sort of control group of goods that's going to have similar idiosyncratic quality, right? So we're going to compare consumption fractions of the recommended versus those that are ex ante of similar quality that are held out. The second challenge is that different mechanisms are typically confounded, right? So exposure and information, it's hard to think about how to decompose those. And so what we do is we effectively ask people what they think about particular movies, which allows us to expose users to them, but not provide them with information. And by collecting this belief data, we can also kind of quantify the informational gains directly by kind of seeing how people update their beliefs before and after recommendation. Okay. And so the kind of key question we're going to ask in this paper is, we're going to use this experimental design to try to quantify the sort of importance of each of these channels. Okay. So first, for the experimental design, we're going to test the following hypotheses, which come from a model. You can find the full details in the paper. Exposure is going to matter, and then recommendation is going to matter beyond this. The second is that recommendation is going to influence beliefs, which influences consumption. So that in particular, the thing that recommendation is doing beyond exposure is providing information. Okay. And so remember, we're directly collecting beliefs, and so we can directly test whether or not consumption probability is increasing in expected quality and decreasing in uncertainty. The second set of hypotheses here is this first chain, right? That basically recommendation provides information, which leads to updating beliefs, which means decreasing uncertainty and shifting expected quality towards predicted quality. The final set of hypotheses are about kind of more dynamic elements. So we're going to first hypothesize that there's spatial correlation. So consumers have more similar beliefs about goods that are closer in attribute space. And second, we're going to posit that conditional on having this spatial correlation, there's going to be informational spillovers, right? Where consumption of a good or recommendation of a good is going to not just influence the uncertainty about that particular good, but also more similar goods as well. Okay. The platform we run this on is a platform called MovieLens. It's one of the earliest deployments of recommendation systems. Here is kind of the interface you can see here. The main thing that we care about is this top row, which has the top picks, right? So these are user-specific recommendations, right? So conditional on the ratings history of the user and all the other ratings on the platform provides personalized recommendations to the users. You can see here, they see the movie poster, the title, and then the personalized predicted rating that the platform has for them. Now, the natural question is, how high quality are these recommendations? And so the MovieLens platform is kind of a benchmark. The data that's generated from it is a benchmark data set in the recommender system community, used in thousands of papers to sort of test out new algorithms. And so we think of the recommendation system here as relatively high quality. The platform is also unbiased, right? So the platform has no commercial interests. And so there's no strategic reasons for consumers to kind of think that the recommendations are biased in some direction. Okay. Now, the main randomization is as follows, right? So we have subject-specific item-level randomization. And so what happens is for each user, we're going to take the 750 top movies according to the recommendation system. We're going to sort them, and then we're going to bin them into 3 separate groups, right? And the kind of key intuition here is we're effectively using the output of the recommendation to kind of do a stratified sampling to hold fixed quality across groups, right? So the 3 groups are going to be, the first is going to be called recommendation. In this group, what we're going to do is we're going to ask people what they think about the movies on the platform. And these are the only set of movies from these 750 that will ever show up in that top picks, okay? The second is what we call elicitation only, right? And so for these movies, they'll never show up in that top picks, right? These movies will never show up on the user's top picks. But what we will do is we'll have a separate survey where we'll ask people what they think about them, right? And this is going to expose them to the movie without getting them this information that implicitly is coming from recommendation. And then finally, the last group is going to be a control group, right? And these are the movies that we never elicit beliefs about, nor recommend them. Then what does the experimental intervention look like? So in every period T, where again, a period T is basically just a user showing up to the platform, okay? We have to pick which movies do we ask them about and which movies do we recommend to them, okay? And so we're going to have the platform's predicted rating from the beginning of the study. We're going to fix these. And then every time period, we're going to add some mean zero noise where we calibrated the variance of this noise so that the recommendations on average are still of high quality. And we're going to sort goods according to this noisy ranking, okay? Now, given this noisy ranking in the recommendation group, we're going to take the top 8 goods from that group, right? And so again, because this is mean zero noise, the variance isn't too high, this is going to retain recommendation credibility, right? So recommendations are still going to be high quality, but it's going to generate exogenous variation in kind of the set of recommended goods that as users are using the platform more and more, we're not going to have that the quality is decreasing, okay? Then what are we going to do? We're going to elicit beliefs about the quality of 2 goods in the top 8 from both recommendation and the elicitation only, right? So because of the way that recommendations are constructed, eliciting beliefs from the recommendation group, we're basically going to elicit beliefs about movies before they get recommended. And then when they come back to the platform, after they had it recommended, we're going to ask them again what they think about it, right? And so we're going to see how recommendation shifts beliefs. The control group here is we're going to also do this for the top 8 movies according to the sorting order using the elicitation only group, right? So these are movies that would have been recommended had it not been for this experiment, right? So we're basically doing the same quality fixing for belief updating. And this persistence allows us to detect changes in beliefs, okay? And so what does this belief elicitation look like? So there's 10 movie posters that you see. You can either click seen or not seen. If you click not seen, we ask you using the same 10-point Likert scale that the platform has, how do you think you would rate this movie from 1 to 5 on half star ratings? And then we ask using a 5-point Likert scale, kind of how sure are you of this? Okay. And then if you marked seen, we ask how would you rate this movie? And then we ask when exactly do you think you watched approximately? Okay. And so the belief survey is preceded by a consumption survey, which is going to allow us to kind of complement the ratings log data to determine when a movie was seen. So overall, the data we observe is we see consumption through ratings, we see beliefs, and then we see movie detail page visits, okay? For the recruitment, we're going to target 4,500 platform users. we're going to look for active users, right? Users that have been using the platforms in the past few months, that don't have too many or too few ratings. We get voluntary enrollment. There's no incentivization. We get 14,550 to enroll. All our results are robust using the full sample, but we restrict our focus to kind of 1,007 participants with over 1 survey completion and in the study for 1 week. We pre-register the conclusion of the intervention, and we roll it out from the end of March until the end of October, and we pre-register all the stuff. Okay. So what's the first set of results? The first thing we want to ask is, does recommendation influence consumption? And so, we do this in a few ways. So the first thing I have to talk about is kind of what is the measure of consumption we're using? So people aren't actually watching movies on these platforms. So one, we can use rating, right? Which is basically just I rated the movie. The second is we can use what we call the robust measure, which effectively uses the data from our belief and consumption survey to kind of filter out movies that you rated, but you actually had watched before the intervention period, okay? And so we're gonna report our results for both of these. And then the empirical specifications are pretty simple, right? So the first thing we can do is for each user, they have these 750 movies. We know whether or not they watched it or not, right? And so we can ask the question of kind of, was this an exposure set, recommendation set? We estimate this simple linear probability model. We see that in the baseline, 0.7 percentage points of the control group are consumed. There's a lift of 0.1 percentage points in the exposure set, and then the recommendation set has a further lift of 0.7, right? So pretty large. We then can look at, a less conservative specification, which is effectively kind of, there's a lot of the movies in the 750 that never get exposed or recommended. So we condition on the strata where these things were exposed or recommended. And again, we find, as you would expect, kind of higher effect sizes here because we're actually looking at the movies that were recommended. And then finally, as a final sort of robustness, we can look at the set of movies where they were actually recommended. And so we actually have from the belief survey that at some point they had marked the movie as unseen, and then eventually they saw the movie, okay? And so roughly in terms of effect sizes, we find a small effect, but statistically significant from exposure, but then a recommendation nearly doubles the effect size here, okay? And so then the question we have is kind of what is driving this effect beyond exposure? The first thing we can do is we show that beliefs map to consumption. So this is the consumption probability. This is expected quality and uncertainty. And again, you can kind of see across both cohorts, as expected quality increases, consumption probability decreases. Similarly, as uncertainty increases, consumption probability decreases, okay? Then we turn to hypothesis 3, right? And so the sort of recall that the key identification here is that we repeat belief elicitations of movies of comparable quality, right? And we want to ask the question of does recommendation influence beliefs? And so what we find is some subtlety, right? So we look at the degree of uncertainty, and then we look at kind of how far your beliefs move from the platform's predicted rating. And we find that if you're pretty certain about what you think, a recommendation has little scope for information provision and doesn't do much. But if you're uncertain, then we actually find that both uncertainty decreases and you move closer to the platform's predicted rating, right? So we do find evidence that recommendations affect beliefs, but only if consumers are kind of really uncertain about quality, okay? Now, the next question, so this is kind of looking at the direct effect of information of sort of recommendation. The second question is sort of by making them prominent on the platform's homepage, they may reduce the cost of information acquisition, right? And so the natural question is, do recommendations foster this additional information acquisition? We find that the answer is broadly yes, right? A recommendation group seems to sort of acquire much more information about movies that are recommended relative to the control group. And we find that this information acquisition indeed induces significant shifts in consumer beliefs, right? So there's a reduction of nearly 0.05 for uncertainty, and 0.19 for the difference between the expected and predicted quality. And I should clarify, I realized I didn't, that uncertainty we kind of standardized to be between 0 and 1, and this is kind of kept in its standard scale, right? So this is a quite sizable effect size, okay? And then again, a natural question might be kind of, is all we're picking up from the direct effect here. As all we're picking up here is just that people are more likely to go to the details page. And we have some additional results in the paper which show that there's sort of two distinct information acquisition channels here. The first is the direct one, which the recommendation itself gives some information, which reduces beliefs. And the second is that it sort of influences beliefs further through this indirect channel as well. Okay. Finally, I won't talk about the details of this too much, but effectively, we have a really rich tag genome data set, which allows us to measure distance between movies. And we want to just ask the question of, does information about a good generate spillovers to similar goods? And what we find is pretty strong evidence for a spatial correlation of beliefs, right? So beliefs about The Godfather are more similar to The Godfather 2 than La La Land. We find some evidence, so consumption has some information spillovers. We're watching The Godfather's more informative about The Godfather 2 than La La Land, but we don't see an effect for recommendation spillovers. Okay. So to conclude, what did we do? We ran a field experiment on a movie recommendation platform for 6 months. We tried to isolate the different mechanisms that drive the influence of recommendation systems, right? So we did within subject design at the item level. And so for each user, we had that movies were either in recommendation, elicitation, or control. We collected data on beliefs and tracked movie consumption. We found that both exposure and recommendation have a causal effect on consumption. To explain why recommendation increased consumption beyond exposure, we posited and provided evidence for an informational mechanisms where recommendation influences beliefs. And then we found some dynamic effects where there's some spatial correlation. What are the implications of this? Informational effects here matter. It's not just a search distortion. And the sort of combine our results, it's interesting to think about recommendations as potentially dynamically steering consumption via spillover effects, right? So recommendation increases consumption, which decreases uncertainty about similar goods quality and promotes consumption of similar goods. Thank you, and read the paper for more details. Happy to take questions via email.